So, in this video we are going to talk about derivatives of exponentials and logarithms. You've seen in previous videos how to take derivatives of polynomials, which is to say the variable x to some exponent, which is a number like 1/2, -3, or 3 or 2 and 5. This time we're dealing with different functions. You see the difference is with exponentials, the variable here, x, is in the exponent now. Okay, before it used to be the base, but now the base is just the number and the variable is in the exponent. And in the other function, logs, you see we have ln x. What's a derivative of that? All right, so these are the two functions we're going to go over in this video, just very basically. And in consequent videos, we're going to do some more advanced examples of derivatives of these functions. But just to get started here, if you had to guess what the derivative of this thing would be, what do you think you'd guess? Okay, here's what some people would think it would be based on what you've seen before. So the derivative of b to the x d dx of b to the x. Well, okay, x is the exponent, so let me just drop that down as x. Then you get b to the x minus 1. Done. Right? That's just the power rule. And guess what? That's wrong. Okay, so don't do that. That's a very common mistake. You don't do power rule, or you can never do power rule when there's a variable when the variable is an exponent. Okay, power rule is only applicable when the exponent is just a number, a constant. Okay, so let me just show you the formula then. So the formula instead is, so the d dx, in other words, the derivative of b to the x, is equal to, ready? B to the x, it's just itself, times a little bit extra. Okay, so how does that go again? The derivative of b to the x is itself, and then a little bit of extra, okay, times ln b. So whenever you take the derivative of b to the x, it's always itself times ln of the base. All right, and that's it. It's just that formula. Pretty simple to remember. So let's just do it in an example. So let's say we want to find the derivative of, let's say, 2 to the x. So notice that the variable is x because we're doing d dx of it. We're taking the derivative with respect to x. So we have to use the formula for the derivative of an exponential function, not the power rule. All right, so let me make a note here. Don't use power rule. Okay, so it's really simple. The derivative of that function is 2 to the x times ln 2. Done. Let's say that they ask you to do d dx of 3 times 2 to the x. Well, that's easy. Remember, you could just ignore that 3 because it's just a constant. The derivative passes right through it. And what you get is 3 times, well, itself times the little bit of extra, ln 2. And that's it. Okay? So let's do one more special example, and it's when the base is the number e. So you know this is a special exponential function. How does it go? It goes itself times ln e. But guess what? ln e is always equal to 1. And so you can always ignore it, and you should get simply e to the x. So the derivative of e to the x, this is a nice one to remember, is always itself. And if the base is something else other than e, then you need to remember the little bit of extra, the ln of the base. Okay, so let's move on to logs. What is the derivative of log x, or ln x in this case, the natural logarithm? Let me just give it to you. This is not something that you can guess. And in fact, these formulas, I'm just giving them to you, but actually in a later video, I'll show you how to get them using the chain rule. So what's the derivative of ln x? It's going to be 1 over x. That's just what it is. But there's a little bit of a restriction here. Remember when we went over the natural logarithms, x was always greater than 0. So what happens when you plug in negative x's? Well, you usually can't. So a quick fix for that is just to put in absolute value. Okay? So we put absolute value here and x. So now when you take the absolute value of x, now you're allowed to plug in that into the log because it only takes positive numbers and not 0. And what you get is still 1 over x. All right? So these are the formulas to remember. Basically, if you do ln x, the derivative of it is just 1 over x, whether the absolute value is there or not. And if it's not there, you just have to remember that the only thing you're allowed to plug in is positive numbers right here, positive numbers. Okay, so let's do some quick examples. So let's say you wanted to find the derivative of, 2 times ln x. Then really simple, you ignore the 2, then you take the derivative of ln x, which is just 1 over x. And so you get 2 over x as your answer. All right, so that's pretty much it. So just to wrap it up, we went over 2 formulas here. One for derivatives of exponential functions, the other for the derivatives of log. And there were 2 things you have to remember. For exponential functions, the variable is always going to be in the exponent. That's the key thing you need to look for whenever you decide, should I be using power rule or should I be using this formula for exponential functions. And when it comes to log, remember ln of absolute value of x is equal to, the derivative of ln of absolute value of x is equal to 1 over x. And that's basically it. All right.